Okay, so we're going to touch on something you touched on last year, which is permutations, but we're going to add something else to it this year called combinations. So 10.4 says permutations decide combinations on the back. To find the number of permutations, which is just like the fundamental counting principle, the amount of outcomes that there possibly are. To find the permutation, find all the possible ways of the order that they can be arranged, and use the fundamental counting principle to find the number of possible permutations. An arrangement or listing in where order is important is called a permutation. So that keyword arrangement, or you'll see as we do some word problems that the way they phrase it tells you if it's going to be a permutation or a combination. So then they have this formula for us. Looks kind of scary. This just says number of permutations, that's what P stands for, permutations, where order matters, of n things taken r at a time. So n is really the amount to choose from, or what you can choose from. And R is going to be what you want, or how many you're going to choose. That exclamation point stands for factorial, which you'll see me do an example, so you'll see what that means. So on this side, we're working with permutations. So how many ways can the top five finishers be arranged in a 20-person cross-country race? So if we're setting it up to look like this is a permutation of what do we have to choose from? 20. We're going to choose 5. So if we follow that pattern, n goes first, then r, so n on top, be 20 factorial over 20 minus 5 factorial. That's what that stands for. So to find factorial, you just multiply all of the numbers from 20 all the way down to 0, all the way down to 1. So 20 times 19 times 18 times 17 times 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Should have chosen a smaller number to start with. Over, well, 20 minus 5 is 15, so that's 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Whew. Well, when we have something in the top and the bottom that are the same in a fraction, they simplify out. So all of these are going to simplify. And I'm going to be left with just 20 times 19 times 18 times 17 times 16. So 20 times 19 times 18 times 17 times 16 is still a very large number, but we're going to get 1860480. So 1,860,480 ways. How many ways? Another way to look at that is that there were 5 slots, and there are 20 people for the first one, 19 for the second, 18, 17, and then 16 people, because order matters. Lockers. How many locker combinations, we should actually call them permutations, can be made from the numbers 0 through 30 if each one is only used once? So 1 through 30 is 30, but including 0 actually gives you a permutation of 31 things to choose from, and you're going to choose 3 of them. Usually combinations are made with 3. So if we're only going to use it once, this is a phrase that says order matters, because you're only using it once. It can't be repeated. So that would, if we set it up, it would be 31 factorial over 31 minus 3 factorial. 31 minus 3 factorial, which is going to give us 31 factorial over 27 factorial. And since I know that 27 factorial will be all the ones below 26, 25, 24, I really just need to go 31, 30, 29, oh, this is 28. 28, and then I could do 28, but all of those will be gone after that. So I could simplify those out, and I would be left with 31 times 30 times 29, which is 31 times 30 times 29, 26,970 locker combinations, locker combos. is just another way of saying you have 3 spots. 31 for the first, 30 for the second, 29 for the third. Okay, so using our permutations, we might not do all of these, but 4 choose 3 is going to look like 4 factorial over 4 minus 3 factorial, which would be 4 factorial over 1 factorial. So 4 times 3 times 2 times 1 is 12, 24. 11 factorial over 11 minus 3 factorial is going to be 11 factorial over 11, 10, 9, 8 factorial. So after I get to 8, 11 times 10 times 9 times 8, bringing that down, those are going to go away. So 11 times 10 is 110 times 9 is 990. So you kind of get the idea there. I'm going to do 4 and 5, and then we'll probably call this fight good. How many ways can 15 actors fill up 6 roles in a play? Well, that's a permutation of how many do I choose from? 15. I'm going to choose 6. So that's going to be 15 factorial over 15 minus 6 factorial. So that's 15 factorial over 9 factorial. So 15 times 14 times 13 times 12 times 11 times 9, 10. 11 times 10 times 9. And stop at 9 factorial because those are going to simplify top and bottom. Holy cow. 15 times 14 times 13 times 12. Oops. I have plus sign. Times 13 times 12 times 11 times 10 is 36 million? Nope, 3,603,600 ways. One more. How many ways can 6 runners finish in the first through 6th place in a marathon with 20 runners? Okay, that's a permutation of 20, choose 6. Oh man, this is going to be a long one. So this is 20 factorial over 20 minus 6 factorial. So that's 20 factorial over 14 factorial. So I need to go all the way down 15 till I get to 14 factorial so that I have the same in top and bottom. And then multiply those 20 times 19 times 18 times 17 times 16, 15. Wow, 27907,200. 2,790,000, 27,907,200 ways. It's a lot of possibilities. Okay, so now let's switch gears to combinations. So combination is where things can be used more than once. So like your phone number. Your phone number is a combination. You have the number 5 in there more than once. Your locker combinations, you can have things more than once. To find the possible number of arrangements in item order is not important. So it doesn't matter who gets first, second, or third as long as everybody's a winner. You can find the number of combinations of items by dividing the number of permutations by the set of items of each smaller set can be arranged. So here's how we set this up. Order does not matter. It's a very similar setup, but look like we're multiplying by the possible choices in the bottom because we want to get rid of the duplicates. So example 1, we'll do a few of these and then we'll call it good. How many different sandwiches can be made from 2 types of cheese if the choices are cheddar, Swiss, American Jack, and provolone? So how many do we have to choose? Combination of, we have 1, 2, 3, 4, 5 to choose from. We're choosing 2. So this is going to be 5 factorial over 5 minus 2 factorial times 2 factorial again. So 5 factorial over 3 factorial times 2 factorial. Oops. So if we write that all out, 5 times 4 times 3 times 2 times 1 over, this is 3 times 2 times 1 for the 3 factorial. And 2 factorial is 2 times 1. Well, this goes away here. 3 times 2 times 1. And you can keep simplifying. 4 and 2 simplify, and the 1 will just simplify out. So this will be 5 times 2, or 10 ways. 10 sandwiches. Okay, let's try another one. In a school science class with 42 students, how many 3-person lab teams can be formed? So it's a combination of 42, choose 3. So that's going to look like 42 factorial over 42 minus 3 factorial times 3 factorial. Need all these extra stuff in parentheses. So 42 factorial, 42, oh yeah, that's what I wanted to write. 42 over 42 minus 3 is 39 factorial times 3 factorial. So 42, I'm going to do the top like I did before. 42 times 40, on the back side, 41 times 40 times 39 factorial, so that I can simplify this 39 factorial out, and then I will rewrite usually the smaller number, extend it out, so that I'm left with just what's in the top and what's in the bottom. I know that 2 goes into 42 21 times. I know that 3 goes into 21 7 times. So really I'm just left with 7 times 41 times 40. 7 times 41 times 40. 11,480 teams. Another possibility to do that is to just take 42 times 40 times 41 to the top, then divide it by 6. It would be similar. Okay, so I'm going to skip these since you're seeing them, and I'm just going to go down and do one more of these down here. On your homework, you're going to have to decide if it's a combination or permutation. So this phrase, how many ways, that's a really good indicator of combination. These other ones, only once, filling up a role. You care if you get the lead role. You want to get first place, that's why it's a permutation. Only once, that's why it's a permutation. How many ways, that's usually just indicator that's a combination. How many ways, combination. So just do this one more. We have 40 books to choose from. I'm going to choose 5. I don't care the order because I want to read them all. So that'll be 40 factorial over 40 minus 5 factorial times 5 factorial. So 40 factorial over 35 factorial times 5 factorial. So on the top I need to do 40 times 39 times 38 times 37 times 36, because now my 35 factorials can simplify out. And then I have 5 times 4 times 3 times 2 times 1. So I know that, let's see, this is 20. So those two simplify out, and I know that this will give me a 2, which simplifies with this 2. Let's see, 36 and 12, and that's what I'm left with. 39 times 38 times 37 times 12 in simplest form. 658,008 ways. There'll be a lot of ways to figure out how I can read a book. That's it. Have a great day.